Hello, this is Luke Meyer. I'm in Mr. McCabe's 4th period statistics class, and this is my stats project. For this project, we were to create an analysis of two different variables and find the relationship between the two of something that interested us, and for my project, I decided to do the relationship analysis over unemployment rates and murder rates amongst the 50 states in the U.S. I found it for the year 2012, and I have the information listed, the states listed in order from lowest unemployment rate to highest unemployment rate. I have the unemployment rates right here, and then I have murder rates right next to that right there in correspondence to the state. I put that data in the graph, and I created a scatter plot having the murder rates per 100,000 people on the y-axis, or the response values, and I have unemployment rates at the bottom on the x-axis, percent, which is the percent of each population, as the explanatory values. Looking at this graph, you can see that the graph shows that the data has a weak but positive correlation with a slightly upward trend, and it's not very linear, but you can tell there's a trend. While this is true, for the most part, we can assume that as unemployment rates increase, murder rates also increase. Calculations I did after putting all my data in, I found the LSRL, which is y-cap equals 0.44 plus 0.57x, r equals 0.45, and r squared equals 0.207. Interpretations: the coefficient of determination, or r squared, was 0.207, and this means that 21% change in murder rates that can be accounted for by murder rates on unemployment rates. Also, as the unemployment rate increases, the murder rate also increases. The correlation, or R, was 0.45, and this means that the correlation between the two variables is weak, but it is still positive, and it is possible to see a positive upward trend while and it's not very linear. Residual charting, I did again the states in order from lowest unemployment rate to highest unemployment rate, and corresponded its and have its residual in correspondence to its state right next to it. I put it in the data to create a the graph in part of the calculator to create a residual plot. I have all the data in right here, and when you look at this, you can see that the model is a good fit for the data because it doesn't have a pattern, meaning that it is linear, and so if it did have a pattern, it wouldn't be very accurate, but because this doesn't have a pattern, it is good. There was one outlier we see right here off in the very top, away from all the others, and that was for the state of Louisiana. It had a unemployment rate of 6.5 and a murder rate of 10.9, and it's an outlier because the murder rate was significantly higher than all the other states in this data, especially for the states that have the same or near the same unemployment rate. And this causes a change in data analysis, and it will cause the LSR of the data or the line of best fit to shift towards the outlier, which in this case will shift it upwards, and this will increase the value of the predicted values for each data point on the graph. I have right here the equation we used, which was y-cap equals a plus bx, and plugged in my data, which was y-cap equals 0.44 plus 0.5x, and we had to create two different questions to find our own predictions, and here we're trying to find y, or what y-cap would be, and I plugged in just a random number, 8.3, and so we got 5.171, and this means that if a state had an unemployment rate of 8.3%, their predicted murder rate value would be 5.17 per 1,000 people in the year 2012. Here we're trying to find x because we already know what y-cap would be, and we got 10.9, and this means that if a state has a murder rate of 6.7, their predicted unemployment rate value would be 10.9% of the population in the year 2012. And these are the citations for the sites I used. I used the Bureau of Labor Statistics, and I also used the Death Penalty Information Center. Thank you.